All right, team. Quiz 2 review, properties of radicals. Radical is just the square root sign, so properties of square roots if you'd like that better. So all a radical is the opposite of squaring. You're kind of undoing a square. So for this one, square root of 9 is kind of like a puzzle. You're thinking, what times itself equals 9? In this case, it happens to be 3, because 3 times 3 is 9. So 9 can be described as a perfect square, as can 25. So what times what equals 25? Sometimes you can just press a button in your calculator, sometimes you have it memorized, sometimes you look at your times tables. There are lots of right ways to solve these different puzzles. So the square root of 25 is just 5, because 5 times 5 is 25. Great, looking at 100. What times itself equals 100? In this case, it happens to be 10. 10 times 10 is 100. Similarly, 625. You might not have this one memorized, that's okay. Most of your calculators have a button where you can help you find this. Or we can do a little just like guess and check action. We know it's bigger than 10, but it's, is it bigger than 20? Well, what is 20 times 20? 20 times 20 is 400. So it's going to be some number bigger than 20. Let's try 25. 25 times 25. Oh, boom, we got it. That's 625. So 25 times 25 is 625. There's not like a nice and neat way to calculate these by hand. A lot of times it's a little bit of guess and check, a little bit of recognizing patterns, sometimes just straight memorizing. Like you should have some of the smaller squares memorized. Maybe not something this big. For that, we have calculators. Okay, let's keep rolling. Square root of x squared. I said a moment ago, squaring and square rooting are inverse operations, so they undo one another. Another way to look at this is what times what equals x squared? Well, we know from the previous video, x times x is x squared. So the square root of x squared is just x. You could look at that as the square root and the square canceling one another out, and x is all that remains. Square root of x to the 6th power. So what times itself is x to the 6th power? If you're not sure about that, make sure to check that quiz 1 review video. We went over this. This one is just going to be y to the 3rd power. Because y to the 3rd power times y to the 3rd power is y to the 6th power. So when you square root y to the 6th, y to the 3rd is what remains. Again, if that's not super clear, if that doesn't make sense, check out that last video. I explained stuff like that. Okay, now what if they're not perfect squares? This number is really close to the 25, but the response, I'm not going to say really close to 5. It doesn't quite work like that. Sometimes we're not going to get perfect squares. So what we're going to do here is create a little bit of a factoring tree. We're going to recreate this radical here with numbers that multiply up to 24, and you'll see why here in a moment. So notice here that 2 times 12 is 24. 12 can be broken down as 2 times 6, and 6 can be broken down as 2 times 3. So my claim here, this isn't our final answer, is that 2 times 2 times 2 times, there's 3 of them, times 3 has the same value as the square root of 24. And that's easy to verify. 2 times 2 is 4, times 2 is 8, times 3 is 24. Okay, well, why? What's the point of that? Well, we can break this down a little bit. We can say 2 times 2 is 4, and then 2 times 3 is 6. Again, 4 times 6 is still 24. We're still working with the same number, just we're looking at it from a different perspective. Square root of 4, that one's a perfect square. So we can work with that and say that this is 2 times the square root of 6. And I know that that's annoying, but it doesn't get simpler. That's the simplest that square root of 24 can get, is 2 times the square root of 6. Okay, let's do the same thing with this 84. Again, break it down into smaller factors. I'm noticing it's even, so I'm just going to start with the evens. 2 and 42, 2 and 21, 3 and 7. Okay, so this is going to be the square root of 2 times 2 times 3 times 7, which is square root of 4 times the square root of 21. Again, verify this as you go. 4 times 21 is still 84. We're still working with the same number. Square root of 4 is still 2. Root 21 doesn't have anything smaller we can do. So the solution here, or the simplified version, I'm not even going to call it a solution, is 2 times the square root of 21. Okay, let's talk about if we're multiplying some radicals together. It's really, we've already actually practiced this. We've undid this just a moment ago. So if you understood what was going on there, these will be way easier. The square root of 5 times the square root of 20, we can say that that is the same thing as the square root of 100. 5 times 20 is 100. And then, of course, 100 is a perfect square. So the square root of 5 times the square root of 20 is just 10. Nice. This one here, 2 times 8 is 16. So we can say that this is the same thing as the square root of 16. And, of course, again, 16 is a perfect square. So the answer of the square root of 2 times the square root of 8 is just 4. No square roots, just positive 4. Lastly, square root of 5 times the square root of 10. That's the square root of 50. That one's not a perfect square, unfortunately. So we're going to break it down like we did with these ones just a moment ago. Create a little factoring tree. I know that 2 times 25 is 50. I know that 5 times 5 is 25. So this one is going to be the square root of 2 times 5 times 5. And I know that 5 times 5 is 25. So I'm going to split this up because I know that 25 is a perfect square. That's 5 times 5. So I'm going to simplify that version, or that piece of the puzzle, and leave the root 2 as root 2. So the square root of 5 times the square root of 10 is just 5 times the square root of 2 in simplest form. Okay, team, we're getting close. Stick with me. Division now. So this was our multiplication. Let's talk division. Here we have the square root of 90 divided by the square root of 10. So we can actually put these under the same radical. We can say that this is the same thing as the square root of 90 over 10. And 90 over 10, that's something we can do. That's pretty quick and easy. 90 divided by 10 is just 9. And the square root of 9, that's 3. We've already done that part on the board over there. So the square root of 90 divided by the square root of 10 is just 3. Cool. Last one. Square root of 50 divided by the square root of 2. Let's approach it the same way. Underneath the radical, 50 over 2. Half of 50 is 25. So we end up with the square root of 25, which is just 5. Okay. Finding the square root or using the radical as the opposite operation as squaring something. A lot of times in your calculator, the square root button is kind of hidden behind the square button. On mine, if I click this button, it squares. If I click second and then press the same button, it square roots it. That might be helpful for you. I think the same is true in the iPhone calculator and a bunch of others as well. So you really just look, they're all their own unique little puzzle where you're looking for some number that when you multiply it by itself, it equals the number you're chasing, the number that's underneath the radical. Okay, check this out. Watch it again if you need to. Slow it down, speed it up. Ask me questions if you still have them. You got this.